So the topic we are going to discuss today is robot kinematics. A natural question to ask is, why is the study of robot kinematics useful? The answer is that a lot can be achieved in the real world through robots just by effectively using the kinematics of robots. For example, you could have a robot and that is required to say press at certain locations in the environment. Okay, so say at location 1 and location 2, and it is an industrial setting, so these locations are known completely well, so you know the x y z coordinates. You could have uh, a frame of the your your workplace, right? And you could have a frame of the robot, say R. So this is the world frame, and you could have the coordinates x, y, and z coordinates of the xyz coordinates of these points in the world frame. So if you have the xyz coordinates of these points in the world frame, you can use you can transform these points. You can ask the question of what are these points in the frame of the robot, and once you get these points in the frame of the robot, you can where the tip of the robot has to reach, right? So it has to reach point 1 and point 2, and for that, what are the joint angles? So this all these questions, transforming these points expressed in the world frame, right, to the robot frame, and then determining the joint angles that will make the tip of the robot reach these 2 points. And further, if there are some time limitations, so at time t1 it has to reach the point 1, and at time t2 it has to reach point 2. So all of this can be achieved by using kinematics. For example, the transformation from the world frame to the robot frame is achieved using something called homogeneous transformation matrix, and the joint angles are determined using something known as the inverse kinematics, right? So we could have forward kinematics and inverse kinematics, and these are the topics that we are going to study first. So forward kinematics is asking the question, given theta or the joint angles, find x or the position of the tip. So if theta 1 and theta 2 is given for these joints, we have to find what is the position of the tip. So this is forward kinematics. Inverse kinematics is exactly the inverse question. Given the tip of the robot x, find theta, right? And for the system that we are studying right now, it is an open chain manipulator. Forward kinematics is a straightforward thing, and inverse kinematics is a little more involved, right? So let us properly define what our system is, and then in the next lecture we will try to understand how to do the forward kinematics and inverse kinematics for this system, right? So our system is something like this. It is what is often called a RR robot. So a revolute. So it's a revolute robot. It looks something like this. So it has two links and two revolute joints. So the link, this is the first link. Let us say it has length L1. There's a second link. It has length L2. Let us say the first link makes an angle theta 1 with the horizontal. Let us also choose a coordinate frame here, x and y, centered at the first joint, right? And the second link makes an angle theta 2 with the direction of the first link, right? So this is the system that we are going to study. And the first question we are going to ask is, given theta 1 and theta 2, what is the position of this tip? So if I call it xt and yt, the position of the tip, the coordinates of the tip of the robot, what is the x coordinate and what is the y coordinate of the tip of the robot? This is the first question we are going to address. And you can easily find what is the answer for this. The x coordinate will be the projection of L1 in the x direction plus the projection of L2 in the x direction, right? So it is L1 cos theta 1 plus L2 cos theta 1 plus theta 2, right? This theta 1 and theta 2. Similarly, the y coordinate, this height will be L1 sine theta 1 plus L2 sine theta 1 plus theta 2. So that is a simple answer to it. And in the next lecture we are going to study what uh, will write these expressions for forward kinematics, and we will also study what is the solution for inverse kinematics for this robot. Thank you.